So now we're going to look at the weighing method, and this is on page 17 in your booklet, or maybe 16 depending what way you've numbered it. This apparatus works by recording the mass, and if the leafy shoot is left there for a few days, you'll find that, well, transpiration should occur and you'll get water being lost from the leaves, as we say, by transpiration. That means that actually the apparatus will have got lighter. It will have decreased in mass. So if you record the mass at the beginning of the experiment and then maybe the next day or 2 days later, the difference in mass will be due to the water that's been lost by transpiration. So you can do a very simple calculation. Now, when we set this apparatus up, we need to be very careful, because if you just leave a beaker of water sitting at the side of the room, maybe leave a glass with a wee bit of liquid at the bottom, come back the next day, some of it will have evaporated. So you'll notice here that there's a layer of oil at the top of the water, and that will float on the top of the water, and that will stop any water from evaporating and being lost. Now, so you cut the leafy shoot or the twig, put it into the apparatus. The cotton wool just helps balance it and sort of secure it in position. Set it on the electronic balance, record the mass at the beginning, and then come back in a day or maybe 2 days, record the final mass. Now, sometimes you might want to do an experiment over a week and record the mass every day. But in the experiment, in your booklet, it talks about coming back in 2 days. So that's what we're going to look at. So if we look at the just underneath the diagram, now I want to actually give you the name for this apparatus. This is called the weight potometer. Earlier we talked about the bubble potometer, but in this we're recording the mass or the weight, so this is called the weight potometer. It's a lot easier to use. So halfway down that page it tells you about a year 12 pupil who set up the apparatus and recorded the initial mass, and then 2 days later recorded the final mass. And then her friend set up a similar experiment, except this time the leafy shoot was enclosed in a clear plastic bag. And again, she's recorded the initial mass and the final mass. So the first thing you have to do is draw a table to show these results. So I've tried to use a ruler, which is pretty difficult on this setup. But in the first column, we're going to put down what the difference in the two experiments was. What did we actually change? So it was the plastic bag. So something like, was the plant covered in a plastic bag? And in the first one, no, it wasn't. The second one, yes, it was. So we have the initial mass, then we have the final mass, or you could have mass after 2 days. And then it tells us that we need to record the change in mass. So if we read the first sentence in this, it says, a year 12 pupil set up the apparatus, recorded the initial mass as 250.38 grams. 2 days later, the mass was 246.24. Okay, now if you do that, you will actually lose marks, because you shouldn't have the gram sign in the body of your table. So these are your headings up here. All your units should go in the headings. So you need to have grams there and put a slash in grams. Change in mass, that's going to be grams as well. So what you need to do is pause the video, write in the other experiment results and calculate the change in mass. Okay. Right. Once you've done that, you should realise that The plant that wasn't in the bag had a change in mass of minus 4.14 grams, and the other one was minus 0.51 grams. And the minus signs are important. They say that we've lost mass, and so we're going to assume that the loss in mass was due to transpiration. The conclusions. What are we looking at in this experiment? The fact the plant was in a plastic bag means that the conditions were humid. So the environmental factor that we're investigating is the effect of humidity. And then you're asked, what conclusion can you draw from the investigation? Well, when there was high humidity, the rate of transpiration was very low, and it says use data to support your conclusion. So you need to say, as the plant only lost 0.51 grams, whereas the plant that was in the air or had no humidity lost 4.14 grams. Therefore, transpiration was much faster. Explain your conclusion. Well, you need to say that the plastic bag traps moisture, which is lost from the plant by transpiration. And so therefore there's a high humidity inside the bag. How does that affect transpiration? If we sketch out our leaf, so we've got all these cells here in the mesophyll. This is the upper epidermis, and the lower epidermis is down here. So these are our guard cells here, and this is our stoma here. So if you have water evaporating from the spongy mesophyll cells, the water vapour is going to gather inside the airspace. If it's very dry conditions, you've got a steep concentration gradient. In other words, there's a big difference between the concentration of water vapour inside the leaf and the water vapour outside the leaf, and therefore you'll have a fast rate of diffusion out, fast rate of transpiration. If you have a plastic bag around the plant, the water vapour is trapped, and so the water vapour will be in the air, and as you can see there's not such a big concentration gradient or a difference in concentration between the inside and the air outside, and so concentration gradient is much less, therefore the rate of transpiration is going to be much less. And you need to put that into your own words to explain your conclusion at the bottom of the page.